In this introductory lesson on algebra, we will look at the definitions of some key words we will use throughout this module. To begin, however, let's take one step back and ask the question, what is algebra? Now, to make this question less open-ended, I'll ask a more specific question. What does it mean to say that 3x plus 7x is equal to 10x? This is the type of algebraic statement you would have seen in school, and most students will accept the fact that 3x plus 7x does equal 10x. But what does it mean to say this? Well, first we should recognize that the x's here are serving as placeholders that represent numbers. What numbers are they representing? Well, in this case, they are representing every number imaginable. So 3x plus 7x has no particular value, and neither does 10x. The value of 3x plus 7x and the value of 10x depend on the value of x. Now, if we assign a value to x, say x equals 2, then we can evaluate 3x plus 7x by replacing each x with 2. When we evaluate the left-hand side here, we get 20. Similarly, we can evaluate 10x when x equals 2 by replacing each x with 2. When we evaluate the right-hand side here, we get 20. So when x equals 2, 3x plus 7x and 10x both evaluate to be 20. Similarly, if x equals 8, we can evaluate 3x plus 7x and 10x by replacing each x with 8. Now when we evaluate the left-hand side here, we get 80, and when we evaluate the right-hand side, we get 80 as well. So when x equals 8, 3x plus 7x and 10x both evaluate to be 80. Finally, if we evaluate 3x plus 7x and 10x for x equals 17.3, we see that 3x plus 7x and 10x both evaluate to be 173. From here we might make a general comment about 3x plus 7x and 10x. We can say that for every possible value of x, 3x plus 7x will always have the same value as 10x. This kind of generalization is what algebra is all about. Algebra is essentially a tool that uses letters to express general relationships that hold true for all numbers. So later in this module, when we say that x plus 2 times x plus 7 is equal to x squared plus 9x plus 14, we are saying that for every possible value of x plus 2 times x plus 7 and x squared plus 9x plus 14 will have the same evaluation. For example, when x equals 3, the evaluation of x plus 2 times x plus 7 must equal the evaluation of x squared plus 9x plus 14. In this case, both expressions evaluate to be 50 when x equals 3. Similarly, if we let x equal -1, both expressions evaluate to be 6. And in general, both expressions will have the same evaluation for every possible value of x. Okay, now that we've taken care of what algebra is, let's examine some key definitions. The first word is variable. A variable is any symbol, typically a letter, that stands for either a single number or all existing numbers. The next word is constant. This is either a number on its own or a letter or symbol that represents a value that does not change. Some examples include 6, 7.2, and pi. Next we have term. This can be a constant on its own, or it can be the product or quotient of a constant and one or more variables. Some examples include 14, 5x, 8xy cubed, and so on. Now a coefficient is the constant portion of a term. For example, 6 is the coefficient of 6x, and 2/3 is the coefficient of 2y over 3. Now if a term does not appear to have a coefficient, then that coefficient is assumed to be 1. So for example, the coefficient of w squared is assumed to be 1. The next word is expression. This is a collection of one or more terms that are combined using addition and or subtraction. So some examples of expressions include w cubed minus 3x squared plus 5y, x minus 1, and so on. Now a monomial is an expression consisting of one term. A binomial is an expression consisting of two terms, and in general, the word polynomial applies to any expression consisting of one or more terms. Okay, that concludes this introductory lesson. The important takeaway here is that as we work our way through algebra, keep in mind that much of our work is concerned with making general conclusions about the ways in which all numbers behave.